Today I am going to explain about two factors affecting enzyme activity. There are many factors which influence the enzyme activity. The important factors affecting on enzyme activity as follows: enzyme concentration, substrate concentration, hydrogen ion concentration, that is nothing but pH, temperature, light, enzyme activators, enzyme inhibitors. So let us first know about the enzyme concentration. So increase in enzyme concentration which accelerates the velocity of enzyme catalyzed reaction. However, under practical conditions it is not always possible to achieve very high concentration of enzyme because these enzymes being proteins, their molecular weight is usually very high. Hence, we are restricted to work only with very low concentration of enzyme. If there is an excess of enzyme, the amount of substrate transformed increases in a linear manner as seen in this graph. If there is an excess of substrate, the amount transformed decreases rapidly with time. So increasing of enzyme concentration, that increases the rate of catalytic reaction. So next, substrate concentration. So substrate concentration is one of the main factor affecting enzyme activity. So substrate concentration, so here in this graph it shows the rate of reaction increases with the increasing of substrate concentration, but finally a point is reached where there is no increase in reaction with further increase of substrate concentration. At this substrate concentration, all the enzymes get saturated and is present in the form of enzyme substrate complex. Any further increase in substrate concentration cannot increase the amount of enzyme substrate complex. The amount of enzyme becomes limiting. Then hydrogen ion concentration. So here hydrogen ion concentration is nothing but pH. So enzymes are sensitive to changes in pH, changes in the acidity and alkalinity of the reaction medium. So every enzyme has its own range of pH in which it functions most efficiently, and excessive acidity or alkalinity renders them inactive. So certain digestive enzymes prefer a distinctly acidic or alkaline medium. Thus, the digestive enzymes like pepsin, which functions only in an acid medium at a pH between 1.2 to 2. So here the optimum pH of pepsin is 2. Then the trypsin, it's secreted by the intestine, functions in an alkaline medium at about 7.9 to 8.5 pH. But majority of the intracellular enzymes have an optimum pH near neutrally and will not work at all in an acid or an alkaline medium. So enzymes like urease are active only near neutrality. So hydrogen ion concentration may alter the ionization and solubility of the enzymes, the substrate inhibitors and activators. The next, temperature. Temperature is one of the important factor which always affects enzyme catalyzed reaction. As the temperature rises, the rate of reaction increases until a maximum is reached. So you can see in this graph. So here rising in temperature, that also rises the rate of catalyzed reaction, but at higher temperature the rate of reaction rapidly decreases and still higher temperature it comes to an end. So, the temperature at which the rate of reaction is maximum is termed as optimum temperature. So, where the catalyzed reaction is increased, that temperature is calling as optimum temperature. So, during enzyme action, two reactions are simultaneously taking place. One is the catalytic reaction caused by the enzyme, and second one is the denaturation of the enzyme itself. Because of the enzyme denaturation, an enzyme is stable for week at 0 degree centigrade, for days at 10 degree centigrade, for hours at 30 degree centigrade, but for fraction of seconds at 70 degree centigrade. Usually the rate of reaction rises up to 40 degrees centigrade, starts declining from 40 degrees centigrade. The optimum temperature of most enzymes falls between 37 to 40 degrees centigrade. But a few enzymes continue to be active above 60 degrees centigrade also. So light. So light is also one of the important factor which affects the enzyme catalyzed reaction. So enzymes are inactivated by strong light, like ultraviolet light is very effective in destroying enzyme activity, and X-ray may or may not be destroying enzymes depending on the circumstances. Enzyme activators. So enzyme activators, here name itself suggests that it activates the enzyme catalyzed reaction. So certain substances either initiate or enhance the rate of enzyme catalyzed reaction. The substances activates the reaction. Such substances are called activators. The activators can be classified into two groups. One is metallic ion activators and another one is proenzyme activators. So metallic ion activators, in this several enzymes require metallic ions for better activity. Thus, arginase require cobalt, manganese or iron. Then proenzyme activators, the digestive enzyme and the enzyme responsible for coagulation of blood are produced in inactive form. The inactive forms are known as zymogens or proenzymes. For example, zymogens are trypsinogen, pepsinogen and prothrombin. So this type of enzyme activation involves the breaking of some peptide bond, and the rearranged remaining molecule is the catalytically active enzyme. Then enzyme inhibitor. So enzyme inhibitor, here also name itself suggests that substance which inhibit the rate of enzyme reaction are called enzyme inhibitors, and process is termed enzyme inhibition. That means here the reaction will be stopped due to certain substances, like certain compounds like arsenic and other metals such as mercury and silver combine with an enzyme but do not serve as substrates. Thus, they block the catalytic activity of the enzyme and function as inhibitors. So in this, inhibitors are classified into two types: competitive inhibitor and non-competitive inhibitors. So here competitive inhibitors which compete with the substrate for the same active site on enzyme molecules are called competitive inhibitors. For example, dihistidine is a compute for the enzyme liver histidase. So, non-competitive inhibitors. Inhibitors which cannot be displaced from the enzyme molecules by the substrates are called non-competitive inhibitors. For example, two polypeptidases secreted by ascaris, one inhibits pepsin and other trypsin.